this press conference is relating to this ongoing congress which we have in the other auditoria here in this building. It is the theme of this conference is safety engineered nanoparticles and nanotechnologies. And this is an international congress with participants from which amount up to almost to 250. We have the pleasure of having speakers from all around the world, and we are going to hear some of them in this press conference today. And we have decided to start the press conference by a presentation from from industry side, from a small company which is developing these products, and which company is headed by Dr. Asko Vehanen. Dr. Asko Vehanen has been working in this field and related fields for some time, and now he is the CEO of this company called Carbodeon. And I will give the word to Mr. Dr. Asko Vehanen.
Thank you very much, Professor Vainio. I have 7 minutes time to present the company in short, and also how it relates to nanoparticles and their safety issues at the end of the talk. I'm trying to sell you the idea that diamonds are good. They are not nice for girls or jewels, but there's many other applications that the diamonds are excellent, solving a lot of industrial and consumer problems. So we are a technology-oriented company located close to 4 minutes from the Helsinki airport area, next to Jumbo, that many of you might know. I know we are developing two kinds of nanomaterials where I address only the nanodiamonds in this context. We have a fairly broad distribution network of our agents over the world. Biggest sales, I think Japan is the single most biggest sales area. European Union would be bigger as such. And still we have a lot of sales in USA and lots of Asia-Pacific area countries. We are young, as Professor Vainio told, about 6 years old company now. And the nanodiamond, in short, is a true, genuine diamond, like a jewel. The only thing is it's very small. And we make it in the same way that the nature does it. So you need a very high temperature and you need a very high pressure. The difference is that the timing is short, it's milliseconds and not thousands or millions of years. And that's why the nanodiamonds is quite small, around 5 nanometers, very round particle as such. And this explosive pulse is causing the diamonds, and here is a transmission electron microscopy picture of the diamonds showing a fairly spherical and nice and round and also perfect diamond shape. So the question is, what can you do with such a very, very tiny particle that you can only see with a very advanced transmission electron microscope? The answer is that diamond has world record properties, in fact several of them. One being the hardness, as everybody knows. The other one is ability to refract light, which is the basis of jewelry industry. And the third, not so well known, is that the diamond by far is the highest thermal conductor of any material in this planet. And we utilize all of those things in our applications. Short version of the applications, nanodiamond actually is already 50 years old invention. It was invented somewhere a bit east from our country, and it was a military invention first, and now it has become a civilian application since maybe 10-15 years ago. This is one example of a very traditional industrial galvanic coating where a gold layer is deposited on a contact or whatever means customers might have. And you can see that by adding a few grams of nanodiamonds in the galvanic solution, the properties of galvanic gold coating change dramatically. In fact, more than 2 orders of magnitude improvement in wear resistance, so that you cannot scratch the gold anymore if it has some nanodiamonds, a very small amount embedded. This is another example, also fairly old and traditional. Unlike the common thinking that nanodiamond is a very hard particle and putting that in your engine oil or your car might not be a good idea, this actually turns out not to be true. I recommend that everybody will try with your own car. I guarantee that the results are very good. And in a sense, the friction and wear will reduce by 40%. And the gas consumption in the engine will go at least 10% up, sometimes 20% up, sometimes 50% up. We have statistics based on, let's say, thousands of trucks and tens of thousands of kilometers per truck. Last one is that if you have been following the ad in TV that there's magic frying pans with a diamond Teflon, which will never wear. This is one invention done by our colleagues in Switzerland in this case. We also are applying industrial Teflon coatings, nanodiamond composite Teflon coatings, and in this example you can see that the friction of Teflon, which is a very important concept, goes down from 14% in this example to 5%. So 2/3 of improvement on friction, and at the same time wear rate is significantly lower. There are many other applications that I don't have the time to address here. I would just conclude the talk by talking a little bit about the safety issues, because nanoparticle is something that we need some precautions how to work out and avoid damage to our personnel and damage to our customers. So everything is fairly safe if diamond is in water suspension or any other liquid form, but when it's treated as a dry powder, then we need to treat material in our facilities with glove boxes and this dust mask with a certain specification P3. And also do not allow nanoparticles to be exposed in the air, because inhaling the diamond or pure carbon particles is not good. But you can put diamonds in your blood system and you can eat it, and that would not be a health risk, but inhaling would be. So in most cases we find out that a trace amount of particles which are found in the air occasionally are fairly big, and therefore the risk is reduced, because we take all the precautions to avoid it. In addition to that, we will follow our personnel's health situation by regular health controls, mainly using spirometry test, because that is measuring the lung capacity and any possible detrimental effects which might be due to nanodiamonds. We have absolutely observed none during the 6 years that we have been in this business. And very closely we are collaborating with our occupational healthcare company and also with the institute hosting this seminar today. Hereby I thank you very much for your attention.
Okay, thank you very much. And now we have a possibility for a few questions, if any. I think as this presentation by Asko Vehanen was demonstrating the expectations and the promise of using the various nanomaterials in various products the promise is huge. And what is also important that at the same time when we develop these products, we also take care of any potential exposure situations what might occur, and trying to also develop ways how to predict any risks, if any, in these processes. Any questions? Well, diamonds are forever, you know, so. The best friend. Are you just exercising? Okay.
I could.
Well, Kai Savalainen.
Yeah. Well, if you think of application, or when we think of application of nanodiamonds in say motor oils, so what would be the annual production of these materials?
I think the world market today is somewhere of the order of 10 tons, so it's a fairly big market already and growing significantly. And, but the trick, I guess, in this case is that the amount of nanodiamonds needed in oil, it's in the ppm level. So you don't need so many micro nano-sized ball bearings to do the job.
So when you add nanodiamonds into your car, so what would be your advice? How much?
So that the order of magnitude would be 10 to 50 ppm parts per million. We have ready solutions, so anybody who's willing to
so test. So it's not like a spoonful, but you have ready...
No. It's embedded in the phase of a liquid. It's an oil additive. So oil containing nanodiamonds will be poured to the engine oil in connection with the engine oil change. So it's very simple to the customer. And it works.
Okay, thank you for this presentation, which I think gave us an example of a branch of industry which is really looking forward to using the nanomaterials in the products. And the similar situation is in many other situations in various other fields. And that's why I think there is a global interest in not only in nanomaterials and nanotechnology, but also in nanosafety, so that nanosafety should be developed hand in hand with the evolving nanotechnologies.